All right, you guys, welcome to class. This week we're going to be talking about data visualization. Um, so for this module, we're going to go, what are we at, week? Oof. All right, week 12. 12 and 13, I guess. Yeah, so up until this point, everything we've done is to get a little bit of knowledge and mastery over the Python language itself. How do we know what data types to use? How do we store data in them? How do we do if statements? How do we do loops? How do we read data from files? Things like that, right? So just the bare minimum basics of Python. And then from this semester forward, we're going to start doing actual things with those skills. So I think it gets a little bit more interesting, or a little bit more fun at least. So the first one that we're going to introduce this week is how do we show some graphs of our data. And for that material, we just go here to week 12. We click on the visualization content. And that's right here. And I have already done so. And I've got it over here in my VS Code. And I want to apologize, I guess, for being a little bit absent. I've been responding to some emails, but a little delayed. So I apologize. My wife and I just got back from Korea. This is a picture there. We hired a photographer and we rented the traditional uniforms. We went to the palace and did this whole thing. It's a little silly and ridiculous, but it was pretty fun. And so there was a pretty big time difference, and I apologize for being a little bit absent. But now that I'm back, we're going to jump right into this stuff. To do what we're going to do with our graphing, we're going to need to install some software that we probably don't have already. If you follow along with this class and nothing else, you don't have it. If you've done other courses, you may already have it. But to do this, we're going to need two different libraries. One is called NumPy, and the other one's called Pandas. And these are both used for managing our data. And to do the install, the easiest way, you can go do it by hand, but the easiest way, I put the command right here. You would copy this command, this pip install. You would go to the terminal, and then you just paste it in here. So we got the pip install, and this is saying we're going to install not just NumPy and Pandas, I should say. The other big one we're going to use is Matplotlib. That's going to be used for our graphs, and we'll talk about all that stuff a little bit. And then you'd hit enter. I already have this stuff installed, so I don't know what it's going to do for me here. Probably not much. Yeah, it's just seeing it's already installed. But if you don't have it installed, it's going to go ahead and download. You'll see a bunch of progress bars while it's downloading and installing, and then it should be good to go for you. The way you can tell if it actually worked or is done working, I put these two import statements here. If you don't have NumPy or Pandas, these will probably be underlined red. And if you do have them installed, they'll just look normal like this where they're not underlined red. So that's a good way to tell. So take the time, pause the video or whatever to do this portion to install the bits and pieces that we need. We're going to use those later on. Okay. All right. So now let's just jump into some of the content here. The first thing we're going to talk about using is Pandas. We're not going to talk about NumPy specifically. I know I've listed it here, but that's just to help you make sure you have it installed. Pandas is a library. I think I have a link for it somewhere. Right here. Yeah, right here. pandas.pydata.org. It's a tool that's going to help you manage your data easily. And there's a library it relies on or it uses to do that called NumPy. So we're only going to talk about Pandas, but know that behind the scenes, it's doing some of its magic with this other NumPy library. Okay, and so the Pandas library, again, I have the description up here. It's going to help us do, to put our data into graphs, we need to put them into, series of data. So if you've ever done graphing in Excel or with R or with SPSS or whatever the case may be, you put your data into series. In a series, you can think of kind of like an Excel table, right? Columns and rows sort of thing. And it's true, Python can do that in some of the structures, like an array of arrays or, key value pair or something like that. But Pandas has a really nice, easy way to do it. And it helps us to create this tabular data or time series data. And it's just got nice structures for us to use to do it. So that's what we're going to do to put our data into these Pandas structures and get them ready for the graph. And that's why we're doing a little bit of a switch over here. And I'll show you some of the nice things about Pandas. But I wanted to show you first just how simple and easy it is by showing you how hard it would be to do some of these things we want to do without using Pandas library. So a common example, or a example I came up with was we have a large data set of data. Maybe you have all these observations from patients seeing doctors. They would get things taken, like every time you go to the doctor, you're going to get your temperature taken, your weight taken, your height taken, your blood pressure, things like that, right? Just these standard observations. And then after, over the lifetime of your patient, you might have hundreds, maybe, of those sorts of things taken. And then if you multiply that by how many patients you have either in your practice or your unit or your hospital, you can get millions and millions of these sorts of observations. And so then the question is, how can we get some sort of descriptive statistics about that data, either by patient or by unit or by facility or by, even just clinicians who've seen the patients, or however you want to slice the data. And so this is a very simple example. Maybe one of the descriptive pieces of data we want to find out is for this patient, what has been their high temperature. And that's it, right? Just to illustrate a little bit of what we're trying to do. So this is the data here. This is their the temperature data. We'll keep a variable to keep track of the highest temp that this patient's ever been. We'll just start it at 0. And then we're going to loop over that. We're going to go pull out each item of that array one at a time. And we're just going to do a quick little if statement, a little check to say, is the temperature I pulled out of the array bigger than what I'm currently keeping track of? And if it is, I'm going to set my high value to what I just pulled out. I hope that makes sense. Let's run that code just to see what it looks like. Hit F5 for that. Just thinking. Shouldn't be thinking that long. Let's figure out. Oh, there we go. Okay. All right, so we got our data. We initialize our variable. We're just going to loop through, and again, we're pulling out the first ones, right? So 97 is the first one in that list. We're just going to go say, is 97 greater than 0? Of course it is. So we're going to store it there. Now that's our new high temp. Now we're just going to repeat that for each of them until we find a newer or a higher temp, and then we save that one, right? So 98 is higher, 99 is higher, 101 is higher. But now I think we're at 97. Yep. 97 is not higher, so it skips it. 98 is not higher, because remember we're at 101. So I think we found another one here, right? The 101.6 or 0.1. Yep, it's a little bit higher. And again, we're just going to keep doing that. Doing it. Almost done here. Okay, we went through the whole list. And now we can say the highest temperature for that patient is 101.1. And here it is right here on the screen. Okay, so that's pretty easy, right? That's just one piece of data, one attribute about that data. What if we wanted to do a little bit more complicated stuff, saying not just the max temperature, but we want to get the minimum, the max, the mean, the median, whatever, right? All the standard sort of descriptives that we would want to know about it. This is the same data for the temperatures. And so the code's going to look a little bit more complicated, right? So in order to do the min and max, we can do the same sort of logic we had, right? This is the exact same thing. The min will be very similar, it's just a less than sign, right? but it's going to do the same sort of thing. It's going to keep track of it. And then for the average, we have to keep track of all the temperatures that we've had and then divide right here. So we got a running total of temperatures, keep track of all those, then divide by how many observations there were to get the average. And then the median is we would have to sort the temperatures in order from smallest to biggest, and then we'd go grab the middle value to get the median. So we got a little bit to do, and then we would have to print it out here. So let's just watch this work. Set up the data, looping through it, looking for the min and the max. Luckily, there's not too many rows here. Okay, so we went through all of it. So we got a min of 97, a max of 101.1, our running total, which is just all the temperatures added together, 893.7. And then we would just divide that into it to say our average temperature for this patient is 99.3. Then we're going to sort our list of temperatures from low to high and then go grab the middle value, which is what we're doing here. We're just saying how many items are in there, divide by half. That's what the item is we're going to go get. And the median value is 99. So that's pretty interesting, right? The median and the average are very, very similar. And then we just print those out. Right, so 101, 97, 99, whatever, right? So here's just a bunch of descriptive data. Okay. So you can see it starts to get really complicated. And now imagine that we want to do this for not just temperature, but we want to do it for all the attributes, right? We want to do it for your body weight, your height, whatever else to keep track of, right? Just to get sort of this baseline and stuff. As you can see, it would start to get pretty unwieldy to get this information about these series of data and to get the descriptive statistics about it. And so I want to show you there's an easier way to do that, even though we know how to do that, and we can do that here. You can see we did it in like, what was this, like 20, 25 lines of code? It would obviously be much bigger if we want to do it for more series of data. We'd have to do some refactoring, put it into a method, and have some code reuse, but it would still be quite a bit bigger. So I want to show you now that we can use pandas to do a lot of that stuff for free for us, and it's a lot easier to do. So before we can work with it, we just need to import these libraries in. Okay, and a keyword you'll be hearing with pandas is a data frame, or you can think of it like a series. But data frames are like spreadsheets, just simply to think, meaning there's a column and a row, and you can have as many columns and as many rows as you need. And pandas is really efficient in processing data. I was looking this up the other day, because for a lot of this stuff you can do pretty quickly and easily. You can just use, honestly, like Excel to do some of the stuff we're going to do with the graphing. But I learned that Excel has about a 2 gig limit. Once you have 2 gig Excel file, it'll pretty much stop working. And what it can do, processing that much data, it's going to take about a half hour to get through that much data to do what you want it to do. These are the things I just read on the internet. And so the point of using pandas is it's much quicker, much faster, and it can handle a lot more data, not just 2 gig. It's only going to be bound by how much RAM you have on your computer. Like, for example, the computer I'm running now, I think, has 16 gigs of RAM, which is an 8-fold increase, but you can throw it on a server, which has hundreds of gigs of RAM or whatever the case may be, and you can begin to processing much larger amounts of data. So that's some of the benefits you get with pandas, and it's just much faster. But in order to do that, we got to put our data into a data frame. So that's what we're going to do first. We're going to build a pandas data frame. And then I'll show you a little bit after that. But to make our series of data, we add in a label and some of the column names and stuff. So here's a very basic data frame. I'm calling it DF because I'm not very original, but that's just data frame. PD is our pandas library. You can see right here I did an import pandas as PD. So that's where the PD is coming from. So I'm saying go to the PD library that we just imported, and then go to the data frame method. And we're going to call this data frame method, which is going to build us a new object as a data frame. And what we pass in here is an array. You can see right here, square bracket to square bracket. And then within that, we have an array. So it's an array of arrays. And this is going to be our series. So we have 12 items, 12 rows, right? One for each month. And then we have a certain number of columns, right? What do we have? 1, 2, 3, 4, 5, 6. 6 columns, it looks like. 1, 2, 3. Yep, 6. So 12 times 6. And we are just putting it in a nice, easy to read manner like this. And we just separate each value with a comma. It doesn't really matter what we put in here. And then we're just telling it we have 12 rows. And then we have these columns. And so this is sort of our key for the data we're building in our data frame. It's saying that the first bit of data you're seeing here is the month. And then the next column is the hemoglobin A1C. And then you have whole blood count. Then you have the platelets. And then you have the body temperature. And then you have your O2 saturation. So these are the things we've decided to put in there. And we've put them in there in an easy to read way. And we just gave it some sort of headers. Okay. So we built a data frame. Not too big a deal. Let me show you what it looks like though when we print it. It's a little bit fancier print than what we've done in the past. Let me make this a little bit bigger. Right here. Yeah. Just reading that, sorry. So you can see that it's putting it out in sort of this columnar format with rows and columns. Trying to clear this out so we only, sorry, hang on. There's all the data. Sorry. It was overflowing, which is why I wasn't showing all the data. There we go. So here's all the data. Again, 0 through 12, all the month. And you can see it has the column header on it. This looks better than what we were seeing before, right? So it knows that that's the column, and these are the rows. And here's all the data that fits in there. And it's a nice little square, just like Excel. Okay? And it looks like I stopped it from running. So let me show you some of the things we can know about this data once we've got it in the data frame format. Get rid of that. Okay, so we've printed out our data frame. But there's other things we know about it. Once we have it in a data frame, it's going to do some handy dandy things for us. The first thing is it is going to tell us what types of data we're dealing with. It's saying a month is an object. And in this case, it's a string, and strings are treated as objects. So this is just another word saying that you have string type data. It's saying that our hemoglobin is a 64-bit integer, meaning they're whole numbers, and they can use 64 bits to store it. And then we have the whole blood count, which is a float, 64. So again, we can use 64 bits in memory, which you all know what 64 bits means since we did our binary lecture the first week. Float just means it can hold decimal points, not just whole numbers, but it can have the fractional point, right? And then platelets are whole numbers, temperature, whatever. And then you can see all the columns. And that's pretty helpful to see what's in the data there, because you may not, right? Because we knew what this data was because we put it in, but more than likely you're going to be reading it from a file or a database or something, and you're not going to know exactly what that data is. And this gives you a chance to inspect that data and see what's out there, what you're actually working with. And then the index, not super helpful, but it's just telling you have 12 rows. These are the columns, just df.columns, telling you which your order of things you're working with and what they are and what they're called. So the month, the hemoglobin. And then the values, this is just the raw data in the table. And then it's going to calculate the size. And the size is just rows times columns. So it's 6 times 12 is 72. Okay, so we got some basic info that we can work with about the temperatures. But more than likely, you're going to want to read it from a file. So I just wanted to show you how easy it is to read data from a file. You remember a couple modules ago, we did reading and writing of data from files, and it took a little bit of effort. But using pandas now, you can basically do it all in one line, as long as your file is formatted properly. And I didn't actually go check to see if this file is there, so we'll see what happens. I may need to go put it out there in a second. So we call our pandas library, read it as a CSV. We tell it the name of the file, location of what we want. And here we go. It actually looks like it found some stuff and read it in. And again, we can go do the same sort of inspections on it, all that same stuff. So let's go look and then see what data we got for our patients. Right here, it looks like we have 5 patients. It looks like we have patient IDs, gender, I think that's pregnancy status, birth date. I think that's patient name. It's truncating it because it's not enough space to fit it. And then we have medications and I think diagnoses and things like that. Okay, so we were able to read the data in, and if we don't know what the data actually is, we can go look at it. And I wanted to show you this specifically because I think it's a little interesting. Before, when you did it, it showed us like this stuff. It said, it was this stuff. Right here it said month is a string, your hemoglobin is a net 64. But when we do it now, it's saying your gender is a string, whatever this false is a Boolean. It's showing actual data rather than header data. And the reason is because when we set up our first data frame, we told it what all the data would be headed as, whereas now we're reading it from a file, and our file doesn't have the header information. What we could do, though, is we could go to our patients.txt file, put in the very first row what the name of all of the columns would be, like patient name, patient ID, gender, and then it would display something nice and pretty right here when we called the D types, the data types right here. But since we didn't do that, it's just showing us actual data. And again, it's just telling us what kind of data is in there. So it's still somewhat useful in that we know how many columns there are and what type of data is in each column. Yep. And then again, right here on the values, again, it doesn't have a header row, so it's just pulling the first row from the patient data and showing it to you. And then what do we got? The size. So we got 40, so I think it's 5 times 8. We got 40 items. So you can see, anyways, we're able to read that data in and to do stuff with it, which is going to be most likely for your assignments, right? You're going to want to do this way of building your data frame rather than this style, because you're not going to know the data ahead of time. So I just wanted to show you how to do this. Okay, so we've read it in, and here's how you can inspect the stuff that's there. Okay. Anyways, so we get a data frame from pandas, and now we can start to actually do some interesting things. Some of the common stuff I want to show you is just what we were trying to do before, right? I showed you how to write all this code to grab the descriptive statistics about temperature and stuff, and we did like 30 lines of code just for that. So I wanted to show you now that we have a data frame, it can do a lot of that stuff for us for free. I just wanted to show you how to do that. So we go to our data frame. We say go to the temperature column and then grab all the values out of it. And that's this temps right here. And now once we have that column of data, it does some things for us and we can go grab them. And so here's how we can find the minimum value. You can see it's printed. We didn't have to do any logic. We just said, here's a column of data, go find me the min. If you don't like that, the data is already pre-sorted. It sorts it for you. And so I'm just saying go find the 0, which is the first row right here. You can see how they're, and then so you go grab the first one. Likewise for max, you can just call this max method. And you can see these numbers match what we were doing before, the 97 and the 101. And then, you go grab the last item. Right, you go grab the last one. Yeah, a little bit of a caveat there. It's only because it's sorted that's working. But we can start to do a lot more advanced things here than we've done in the past, now that we have these data frames. Here's how we can sort data. If we don't want it sorted one way or another, we can do it by passing in some parameters to it. So we grab our data frame, tell it we wanted to sort the values, so we're calling a method. And into that method, let me see if I can get the IntelliSense to show. Right. It's not showing, I think maybe because it's an imported library. But the first one here is which column are we sorting on, and then what's the direction we're sorting. Ascending's false or ascending's true. And then once we've done that, once we've sorted it, I'm going to grab that column and return it back into my temps array. And so I've got that here. And now I can go find the min and the max right here. So the high one, because we said ascending is false, so it's going to be descending. And so descending is the highest numbers first and the lowest numbers at the bottom. So we just did the opposite of what we had done above. So we sorted it, and then we went and grabbed the first item out of this data frame. And I said, go give me the value of it. And again, that's the 101.3, and that's because we sorted it a different way, that we had to get the bottom one rather than the last one. And likewise, we can go grab the median value, or this one is, I think, the most interesting one, and probably the one that is going to be the easiest for people to use. The describe prints out the common descriptive statistics you would see for data, something you may want to like report on in a paper you're writing for a journal article, for example. So let me show you what that looks like. I called this dataframe.describe, and it grabs the columns that we had, and then it shows you how many data values were in there, what was the average, what's the standard deviation, what was the min value, the max value. There's the max. And then the quartiles in between, right? The 25th percentile, 50th, and 75th. So you can see it's grabbing or creating a lot more data. And a lot easier, right? All we had to do to get that data was called df.describe, and it goes and does that work for us. And it does it generically just based off what kind of data we have entered into the data frame. So that's pretty good. But most likely you're going to want to do something very specific with your data. So I just wanted to give you, I think the rest of these examples here are just how to do specific things in Pandas as like templates or guides that you can use yourself and substitute in. So that's what these next ones are going to be. So let's say we have our data frame, and now we're caring about the O2 saturation percentage. So let's get that and sort it. And now, where is it? Right here. So I put it out right here, and you can see it sorted this from, the O2 column from top to bottom, because we sorted it descending. So it starts with the biggest number at the top, and it sorted it all the way down to have the smallest number at the bottom. Right? So all we did was we just said sort by that, which is easy. Or now we just want to grab specific columns of data. There's two ways to grab columns of data. The most surefire way is this second one with this key, but I wanted to show you that in some cases you can use this dot operator. These keys, these dot operators and these keys are coming from what we called the columns up here, right here, right? We gave these pretty names, and that's what we have to, or can, or have to use to pull the data out. And so right here, right? So we had a whole blood count right here. And because the name is one word without any spaces or any weird symbols, the WBC, we can use that dot operator. Same with month. but we can't use it for these ones that have weird characters or spaces. So it's only single words with just letters in it. So I just wanted to show you that these were options, and it's automatically built and generated based off of your data, right? So this WBC, that's what sort of thing we get is. Or here's the second way of doing it with the key, and the key is always going to work. You just put whatever your key is between the quotes there. When you do it, this is the sort of thing that comes out, right? We know that the column name is WBC, and we know that these are the 12 rows worth of data. This one's obviously not sorted because we sorted it previously off of the O2 percentage. But that's how we can grab just one column's worth of data. But the other way you might want to slice your data is by getting rows rather than columns. So this is how you can grab specific rows, and this is 2 through 4. And it might be confusing because that 4 is not inclusive. So it's really just rows 2 and 3. I don't know why they did it that way. So let me show you that. So here's rows, 2 and 3. But we got all of the data across all the columns, but just for those 2 rows. Okay, so this is a way we can start to slice our data pretty easily. Think about what it would take to have done that in Python, just using for loops or grabbing, specific rows or versus columns. It'd be significantly more complicated than what we just did right here. This is how we get multiple columns and things that you may want to do. Slice your data up that way. So now we have 12 rows because there's 12 months, and then these are the 2 columns that span those. So we got rid of the extra data. So you can start to see how easy and flexible it is to use the pandas to work with our data. In fact, the other thing we can do here is filtering, which is even more snazzy, I think. Because you can see we have, here's the WBC values, right? And you can see it's ranging somewhere between 4 and like 11. And maybe our threshold to determine if there's a high lab result is 6 or whatever. It's an artificial thing. So we just go find all the whole blood cell counts where they have a number in there greater than 6. Because maybe that's our threshold for something. Or for temperatures, right? We could say go find anytime there's a temperature over 98.6, and presumably that means they have a temperature or whatever the case may be. So by using this filtering, just like this, pretty standard, right? We're just saying go to that column, find anything greater than that, and just return it back to me as a data frame, and I just happen to be printing it. So now when we do that and look at it, right here. So it returned us all of the data for all the columns and all the rows, but only where the whole blood count is over 6. And you can see we have 1, 2, 3, 4, 5, 6 results, right? So half the data has a WBC higher than that. Or you can just say, that one's filtering. You could also do a little bit differently where you have a list of data, right? Because this is a single value we're comparing against. This one's where we have maybe lots of values we want to compare against. So we're just saying, go find me all the data in our data frame where the month is in whatever, the summer months, June, July, August. And here's what that would look like. So now we just have the 3 rows, but again, all the columns. So you see it's pretty easy to just grab the little bits and pieces of data that you're going to need to want to graph or to analyze in your report. Okay, and then I'm going to show you here how to change a value really quick. So this one's saying we're going to go change the whole blood count at spot 9, which I think is 7.5 if I'm reading it right. It might be 8.1. We're going to go change it to 6.99. And so this is how you would go do that. Use the equal sign, the assignment operator. Oh, yeah, I got to print it here. There we go. Trying to see which one. .1. Yeah, so it's right here. It used to be 7.5, and we changed it to 6.99 down here. So you can see that that value has changed right here. Okay, and then if you actually want to get your hands on the data, because the data frame is a little bit of an abstract concept, I just wanted to show you how you could actually get in there and grab each piece of data and do things with them yourself, you know, with the normal Python tools that we know how to do with the for loops and the if stuff. If you don't want to use the built-in Pandas stuff, because maybe you want to do other things manually or something that Pandas doesn't know how to do and you do know how to do. This is how you can get a hold of all the data. It's called the iter rows, iterable rows. And just like in before, it returns us the column and the row, and then we're just going to print that out. So I'm choosing to print out the month and the WBC, but I could print out any of the columns we wanted. I could print out all of the data if we wanted. I'm just choosing to do those two rows. I just want to show you that. Okay. So you can see right here it's printing out. I told it to print out the month, which in this, or sorry, the index, and then the month, and then the whole blood count. So the index is 0, January 4.2. So we've got our hands on that data and we're printing it out to the screen, but we can do lots of stuff with it. So I just want to show you how to iterate over the data in case you want to. Okay, so then here's an example that puts all of it together. I was trying to make a really complicated one. This is our last one, I think, for that, yeah. So this is our last one, and I wanted to put everything together so you can see how to make a complicated one. So we're going to go take our data frame, and for this example, I think it's just that we're looking for things that are happening in the summer only where our whole blood count is greater than 9, and we just want to put that out on the screen. Okay. Sorry, I had to cough. Okay, so we got our summer data, is what we're calling it. Print that out to the screen. So you can see here is just all the data for the summer months. And then we're going to further reduce that data or filter that data based off of the value in this column to only get those that are over 9. So you see it dropped June out because June was not. Oh, or July. So we only got August. Let me see if that's right. Yep, so June was 6 or 5.6, which is not, and that's 8.5, it's not. So only August was the only one result we got. And that's right, that holds up. Okay, so hopefully all these examples show you the things, how to do what you need to do to get access to the little bit of data. Once you've loaded it into a Pandas by reading it from a data file, you can do all these things. And there's even more. You can just go do a Google search for Pandas and get a whole lot of stuff. These are just the most common examples that I've used in my life, and I thought that maybe you would be interested in for doing your assignments. But now that we've done all the work, we've done whatever we want to do to filter our and look at our data, we will probably want to save it. And again, you remember from a couple modules ago when we were saving our data, it took a little bit of work. We were writing all the data out field by field, line by line. Well, here, as you can imagine, the Pandas data frame has a way to save it for us. We just call the .to CSV, and we tell it the name we want to save it as. And we do that. And then I want to show you, so that's the entire data set. And we can take the smaller subset that we did with summer and save that. I'll go open these in a second to show you what they look like. So I'm saying take the summer data only, save that to its own separate file. Here's all of the data. Here's just the summer data. And then here's how another way, and again, this is some Pandas niceness, where I'm saying go to the summer data, and I only want to save the whole blood count, just the WBC, and I want to save that. So let me go find that. So let me go open this. So here's the output of all the data. It looks like this. You can see it has the nice headers and then the data. Or here's just the summer months, where again it's a nice header and it only did the summer data that we were talking about. And then this one is going to overwrite that one because I have the same name I wasn't very good at naming here. It's going to overwrite it. And this is just the WBC data. So you can see that it has edited or changed, and now it's just this. And you can see it doesn't have the header. Okay. So hopefully that gets you started in working with pandas. Okay. So the idea here is the whole life cycle of data is we've got some sort of external data, in a database, in a electronic data warehouse for analytics, or we have a text file, whatever the case may be. We have a ton of data. It needs to be massaged and put into a format that we can start working and processing with, right? So that's what the Python part's going to do, right? We read that data in, and then we start iterating over that data. We do whatever we need to do to massage that data to make it, better, to make it computable with our Python language. We do loops and ifs and stuff to get the data how we want. We can save the output of our data, like we've seen. But the whole point is once we have that data loaded and massaged into a computable, easy form, the final thing we'd probably want to do is generate some graphs or run some statistics, right, with that data. Right? You want to see, is there any correlation and causation by running some statistical tests and or generating graphs that you'd want to put in your journal articles or whatever the case may be. So this final step that we're going to talk about is how do we generate the graphs based off this sort of data now? Okay. Yeah, just reading this comment here. Yeah, there's a whole lot more to pandas than I talked about here. And I have a little bit of a problem only showing you examples, but I don't know how else to talk about pandas or graphing for that point besides just showing you examples of what it can do, because the other alternative is we just go look at the stinking documentation, the manual for it, and that's really tedious. So it's more of a matter of like use case. That's how we're going over it. And so I'm sort of making a disclaimer saying there's a whole lot more that it can do than what we just did. So go look at the link. And if there's something you want to do that we didn't talk about, most likely it can do it. We just didn't cover it as an example. These are just some things to get you started. Okay, so we have our data. We did our processing, and now we need to go visualize it. To do that, we're going to use the matplotlib, which came in our install we did up above in our pip install. There's other libraries I'm talking about here. Matplotlib is just the easiest and a really common one. But there's other libraries for graphing, and you're welcome to use those. So here we go. We need to do the import for the matplotlib. I'm going to go grab the sublibrary called the pyplot, and we're going to call it PLT for pyplot, or plot, I guess. Plot. So we got it. Okay. So I'm trying to come up with a use case here for what we could do, and I'm trying to start out with some simple things. And so again, all the rest of these examples for graphing are just going to be example-based, use case-based, because I really don't know how else to talk about these things. If you guys have ideas, please feel free to message me on a better way to discuss these. But the idea is we know what kind of graph we want to make. So I'm going to go through and show you a bunch of different examples on types of graphs you can make, and then we can sort of back into what it takes to make that graph. Like, how does the data need to look? What are the options and parameters we need to pass to make these things happen? But I did some of the common ones, and so we're going to go through that. And so here's a little, scenario, I guess. So say we're a practice or a unit or something, and we're just curious, what's the population of our patients look like, right? Let's say we have 5 doctors in our clinic. We have seen, 2,000 patients this year, or whatever the case may be, this quarter. And we're like, let's actually, figure out what kind of data, what kind of people or patients we're actually seeing, right? And so one of the ways we would want to do that is a common one is, what's the demographics, right? Are we seeing old people, young people, whatever the case may be, right? So for that example, right, we're trying to answer the specific question. We would go look at our EDW, our data warehouse, or our database. We'd go grab the data. We'd have to do some work to massage that data, right? Because in order to know if you're a child or a teen or an adult or a geriatric or an infant, there's logic that goes into place there, right? So we're gonna have to do some loops over the data. go look at their date of birth, do some calculations, figure out if they're in a certain range that we've set for infant, for child, for geriatric. What do those boundaries look like? Maybe it's 62, maybe it's 65, whatever our clinic decides, right? So this is the kind of massaging I'm talking about that we're going to do in Python, right? We've loaded the data. We use Python to do our logic and our massaging. We're going to put that into some sort of series of data that we can then graph. So hopefully this workflow is starting to make a little bit more sense to you. We're building up on it slowly. And so these examples, I'm trying to keep really simple. Okay. I predetermined what these percentages would be, but just know that you're going to have to go through Python and churn over all of that data to actually come up with what these percentages are, right? Okay. So just a few lines of code is all it's going to take to generate a graph. You'll see here in a second. So we go to the PLT, which is our matplotlib, our PLT right there. I'm telling it to go create some subplots. And when it does that, it's going to return two things, a figure and an axis. It's a tuple it's returning us. So here's our figure called figure 1, and here's our axis. I just called it axis 1. You can call these things whatever you want, but it's returning us two things. And we can do with them what we want. I'm only dealing with the axis. I'm not touching the figure for this example. So I'm saying go take that axis, the axes, I guess. I'm not sure how you say that. And I want it to be representative of a pie graph. And here's where your massaged Python data will come in. I'm saying make it a pie graph, and this is my series of data. These happen to correspond to what I had here. This is why I drew this picture to show you, right? 13% of our data is infants, 10% is children, teens, whatever, right? So we did all of our Python processing to come up with these numbers ahead of time. Excuse me. So you wouldn't see hard-coded data like this. I'm trying to explain to you, we did things behind the scenes to get to this point. And then we built some sort of like pandas data frame to hold that data. We're not using a pandas data frame right here, but we will in the subsequent examples. I'm just trying to show you what would go here, right? So your values, your series of data goes here. You're going to give it your labels, right? You can see right here what each of those numbers corresponds to. And these are just some options that we do to make it look a little bit prettier. The auto percent, I mean, all these are optional. You don't have to include any of these things. I'm including them to make them prettier. The auto percent is saying a pie chart should equal 100%. And what is it going to do if the numbers you give it don't equal 100%? And so it's going to go parse these out and try to keep them in proper percentages or proportions. I just saying I don't want it to show a shadow, which it would do by default. And then the start angle, I'm saying, picture a circle, right? 360 degrees. I'm saying start the first slice at the 40-degree spot on a circle. But again, that's optional. And if you don't include that, it'll just start it at the 0 at the top. But I just wanted it a little bit different. That's my own preference. Oh yeah, so this is what I was talking about earlier with the, I'm saying that the axis should be equal. Just ensuring that we are keeping our ratio at 100%. And then finally this is going to actually render on the screen. So brace yourselves, prepare yourselves for what you're about to see. Ta-da! So here we have it. Give you a second to look at it here. So we have the child at 10%, infant at 13, geriatric, blah, 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 blah. So you can see, oh yeah, our clinic is mostly adult and or teens, our two biggest populations. So maybe we can think about, phasing out geriatrics or offloading those to a different clinic or whatever we want to do. I don't know, but you can see how we're starting to build some things together. Okay, so that's our first example. Pretty easy. So I wanted to show you now, I'm trying to get away from using this hard-coded data because that's not really realistic. And I'm trying to show you how we're going to do it now using our data frames. And this is the exact same data frame we did up here above in the earlier example. This bad boy right here. And so for making this next one, the exact same thing is going to happen. I'm saying go create a plot, the subplots. It's going to give us a figure in the axes. I'm saying go make a pie chart. This time, instead of putting in these numbers in the array form, I'm saying go to my data frame and go to my temperature and Fahrenheit columns and give me the values, meaning give me those numbers that are in there. So that's what's going to be in there. And then likewise here for the labels, I'm not going to hard code those. I'm going to instead go to my data frame and say I want it to be labeled with the months that it corresponds to. And then the rest of this stuff is the same stuff we had above. And you should see something a little bit different and a little bit interesting right here, Tadao. So this one's pretty interesting, or it's different. Because the value, because you can see it has January through whatever. But it doesn't actually show any temperature percentages. And this is what I was trying to show you. Some of the data, I specifically made it this way just to show you. Some of the data doesn't lend itself to certain graphs, right? Because the temperature, for example, those are like 98.6, right? 101.3, 97, or whatever the temperatures were, right? But pie graphs need to equal 100%. And so it doesn't know what to do with that because all of those numbers added up to like 893, I think we saw on an earlier example, right? So it's like, I don't know what to do with that. That's where this little guy came in saying, we want this auto percentage thing to happen. So you're going to force it to equal 100. And so it finds it proportionately. You can see they're not all the same values, right? There's a lot of 8.3s and 8.4s, but there's an 8.6, which is a higher one, right? 8.4 is higher, 8.2 is lower. So what it does is it proportionally goes and looks at the data and tries to make it equal to 100. It's saying, all right, in this case, December had a really high value proportionately out of all the data. It accounted for 8.6 of all of that data. And these guys accounted for the lowest, which is 8.2% of all that data. And so you can see that it's forcing it because it wouldn't make sense if you were to say 98, 101, because that doesn't equal 100 in charts. Like pie graphs aren't meant to handle this sort of data. If you want to do that sort of data, you should probably do a line graph or a bar graph or something. So I just wanted to show you, even though you're generating a graph, it may be sort of nonsensical or not what you're expecting. The other thing I wanted to point out, I didn't have it mentioned in the comments, but once you've generated a graph, it's pretty easy to save and to work with it. I haven't actually, so you can zoom in, right? You can do stuff like that. Oops. You can space it. Let me reset things here. You can move it around, see how it's, as I modify things, the graph is changing, right? And then once I have it in a thing that I want, I can save it. So I can use it, and again, in my report, my journal article, my whatever I want to do. You have some choices. The PNG is the most common. PNG and SVG are the ones you'd probably want to use because those are easily put into like Word docs and PDFs and things like that. But you can do whatever you want, right? And you can save the work that you just did, your graph. Okay. Oh yeah, so I have a little blurb talking about that. Okay, so now let's try to plot the temperatures in a meaningful way. And so instead of using pi, so it's all the same code, but instead of using pi, we're gonna use plot. It's all the same sort of stuff. I didn't put any other things in the default like I did here with the shadows and the angles and stuff. I just let it do whatever it's gonna do. I let it use the defaults. But I'm saying go grab the temperatures in Fahrenheit, the values of them, and then plot those against the month values. The only difference here is I put a title on it. The pie chart we've done in the past didn't have a title, but you may want to add a title to your graph. So I'm just saying this is a bar graph or a line graph or a scatter plot or whatever of patient temperatures. Okay, so that's the only thing different really. And again, we're just doing this by example. So here we go. We got patient temperatures as our title, and we have a connected line graph. This one looks a little funny, right? I did this on purpose again, just to show you. Because I told it that this should be the Y and this should be the X. And it really doesn't make a lot of sense looking at it this way, right? Maybe it does. Maybe this is what you want. But typically you probably want to switch these axes. And so I was going to show you how easy it is just to switch the axes right here on this axis.plot. I put temperature first, month second. All I gotta do is swap that. Do month first, temperature second. That's the only change. It's the only difference between this next example. And there you go. That looks a little bit better, right? So pretty easy. And again, this matplotlib is very, very easy to use, but you can sort of see a trend for this patient's temperatures maybe, that they started getting a fever in October and it kept getting higher until December. Probably not great, but you get the idea. Okay. So we can do the exact same thing as a scatter plot. You can see right here, we did pi before, we did plot this time, and now we're going to use a scatter. And that's the only difference we're doing here, is we're just changing it from a plot to a scatter. Just to show you what that looks like. So it's the exact same thing, it's just not connected by a line. These are generally more interesting to use when you're going to do like a regression coefficient line on your graph or something, right? You'd put the scatter plot and then you'd try to find a curve to fit. Anyways. Okay. So those examples have all been single graphs. It's probably going to be pretty common that you would want to create multiple graphs at once. For example, if you wanted to show like a dashboard style thing, or if you wanted to show information that sort of goes together. What's the word for that? I don't know, I'm blanking on it, but you want to show lots of different data in different graphs. So I'm going to show you how we can do that. This one's a little bit more complicated to understand, but not a ton. So I'm saying just like we did before, go to my plot.subplots. This time I'm passing in some parameters. I haven't done that before. It's always been empty. I'm saying go create two of them, first one and the second one, and then they're going to share the y-axis. That's what I'm saying. So then when it renders them, it knows to share that axis. And now it's going to give me back two axes, right? 1 and 2 for the first and the second one. And the first one's a plot, connected lines, and it's showing the month and the temperature. The second one is also a plot, connected line, showing the month and the whole blood count. So you can see those are related data potentially, and then they're sharing the axis of month. And I gave it a different title, the second one. So let's see what that looks like. Not great. I mean, we can see, yeah, so in this case it doesn't look great, but you can see we have two different graphs going on. Temperatures are pretty big numbers compared to the whole blood count, so they're kind of all over the place, a huge range, and then the months are all sort of squashed. So let's see if we can improve this a little bit, right? Let's try to make that a little bit better looking. So I'm going to do the same thing. This time, instead of sharing the y-axis, I'm going to share the x-axis. It looks like that's going to be the pretty much the only difference here. Just double checking. So instead of having our graphs horizontal or vertical, like they were before, tall, now we're going to go wide, and they should look a little bit better. So now we can kind of start to see them side by side, and now they each have their own scale, right? There's not all that big void in between. So this one looks a little bit better. But again, this is just what we got to start doing. We got to start tinkering with our graphs to make them a little bit better. Oh, yeah. So this one, double checking here. The only difference here is I swapped. So the 1 and the 2 that we've done before right here, just this 1, 2, this 1, 2. I changed it here to 2, 1. And what these first ones are talking about is columns and rows, right? So I'm saying go create a column with 2 rows. This one's saying to write 2 rows with 1 column, for example. And so now the difference here is you can say, are you going to put them tall or are you going to put them wide? I'll show you here just to show you what the difference is. Right, so this one's on top of each other instead of next to each other. And so I've decided that this looks better because now they're able to share this same x-axis of the months, right? They each don't have to have their own. Whereas before they were getting jumbled and mashed together. And now they have their own scales, right? So they each have their own scales and they're sharing the month. And so I think this one's probably the best I would know how to do for plotting these two datas together. All right, and then you can just go save your work. Easy. what's the difference here? Looks like maybe I just titled them differently. I think it's the same stuff, but just different titles. Yeah, so I added temperature and the WBC just so you know what the data is you're looking at. Pretty easy. Okay, this next one is a polar graph. Definitely don't use it very often, and none of the data that we had in our data frame I thought really represented data that you'd want to put into a polar graph. So I'm creating some fake data here. We're creating a sine wave, and we're filling in a lot of points from that sine wave to get us our x and y's. You don't really need to worry about that. Other than I just wanted to show you how to make a polar plot. Right here. When we're creating our subplots, I'm saying go create this polar one, and then I'm passing it in. We're going to have the first polar plot be a plot style, meaning it's connected by lines. And the second polar plot is going to be scattered, meaning it's just the points and not the lines. Hopefully that makes sense. You'll see it when you see it. And this one's saying 2 by 2. So we're going to have 2 rows and 2 columns. So it should be generating 4 graphs for us. But I've only told it what to do with 2 of them. So the other 2 will probably be empty, is my guess. Yes, great. That's exactly what I was expecting. So we have 4 graphs. These are polar plots, which is basically like looking at the North Pole down, right? And again, this one's all the connected lines. These ones are just dots, but it turns out that those dots are so close it looks like lines anyways. You can start to see there's some distinction right there. Okay, so if you want to do polar plots, and also this is how you would do 2 by 2 graphs to get 4 graphs in total. Right? It doesn't have to be polar plots. You could do a bar graph and a line graph and a pie chart and a whatever if you just wanted 4. That was the example right here of how you would do that. Right? You'd say 2 by 2. Okay. So now the next idea is I just want to create one graph. Right, so we're going back. Those were just examples. So now we're going to try to create a bar graph that has all the data that we've got in our data frame. Remember what we have in there is not just months. That's just one of the axes. But we have temperature, hemoglobin, whole blood count, O2%, and our platelets, right? So we want to create a graph that has all that stuff plotted together in one big graph. So this is one graph with a lot of series, which we haven't done that yet. So this is showing you how to make a multi-series graph. So I'm just grabbing that stuff out of my data frame. Excuse me. We're sorting the labels. We're telling it how big that these labels are going to be. This is going to our plots. We're creating our subplots. This is something you haven't seen yet, but I'm saying I'm describing what I want the bars to look like and be placed on the graph. So there's a little bit of math involved here, but you don't have to do this. And if you don't do this, all of the bars will just be rendered right on top of each other, and they'll start to stack on top of each other, and they'll hide stuff behind it. And so what I'm doing is I'm telling it to sort of stagger them a little bit. I'm saying go to the left of where you would normally do it, go to the right of where you would normally do it. And this one's like go twice as much as you would over one way or the other way, and 4 times as much. So I'm trying to just stagger the spacing of where these bars are going to be rendered. You'll see it's still not really great. I could do better, but this is just to show you an idea. And this is, how we want to label it in the graph, what we want to call it, stuff like that. And then this is saying I want to turn on the legend. We haven't seen that before. And this auto label is right there. It is. It's a little bit it's a method I wrote. And again, this is probably a little bit more complicated than you'll probably want to do, but I'm just trying to give you as much breadth and depth as I can on these examples in case you do want to do something fancier. I'm saying for these datas, I'm trying to figure out where you should put the label so that you're not stepping on somebody else's toes. That's all we're doing here. It's just doing a little bit of math to figure out where to put some things. And then finally, we're just going to show it. Oh, and this is our last example. Okay, so this is it. So let me just step this through and we can see it. So we're grabbing all the data. Right, we got all of our data, easy. Created our subplots, creating our rectangle areas. We're saying which one's going to be labeled for the X or the Y. And then we're setting a title, telling it how often to put a line on the X-axis. Oh, geez. Looks like I'm getting an issue going on there. I haven't seen that before. That's interesting. Okay, and now hopefully that didn't cause an issue. Let's see if it actually generates. Hooray! Okay, so we have our legend with the colors, which are configurable. These are the values. These are the months. And then you can see it's plotting the data. So for January, here's all the 5 types of data. Right, and then for February, March, April, May. Right, it's not very pretty. And you can see at the top of the bar chart, there's these numbers. That's what this auto label was doing. It was finding out where to put that specific thing on the graph. Okay, so here it is. There's the graph we generated. It's not very pretty, but you get the idea, right? I just want to show you how to put multiple series into one big graph. And so that's for what we're trying to do, not necessarily just this week, but with the actual like midterm, or sorry, not midterm, the group project. Yeah, these group projects. You may want to generate some graphs. And so next week we're going to talk about Jupyter. And you can create the same sort of graphs, or Jupyter will display, I should say, the same sort of graphs. And then that's basically it. We're going to do some Jupyter and some source control stuff. And then we'll have Thanksgiving break, and then it's time to do our group projects, right? To present them and or to turn them in or whatever we're going to do with them. So we're just about done. So hopefully this video has helped you. And again, always just shoot me emails. And again, now that I'm back from traveling, I will respond to them as usual. And we're going to meet this week. I sent out an announcement to meet this week on Friday. Hopefully we can go over whatever questions are tripping you up, or whatever questions you have about assignments or grades or what's expected for the term project or anything. Okay, thanks.